right, hello everyone. We're doing Math Skills 1. This is for Unit 1. First off, measurements. They always have two parts. A numerical part, sometimes called the factor. You've heard of it in math. And then they have a dimension. This is called a label or a unit. I'm very stickler about this, so just remember that. Not only do we have to tell how much there is, that number, but we have to tell what it is that we have just measured. And so in mathematics, units are inconsistently used. You notice that you don't use them a lot in math. This is because much of mathematics discusses the relationship between pure numbers and not the use of a number which describes the amount of something. Many students have the unfortunate tendency to think units are unnecessary, but they kind of are. You can't just say, I have two. Well, to what? To apples, to cars, to pencils. You got to give that numerical, or not the numerical, but the label to it, the unit. And they are very, 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 very necessary. Okay? So units of measurement. We're going to look at the basic units, fundamental versus derived, and metric prefixes. So first off, we got this qualitative and quantitative, two different vocab words. Very important, something you should write down. But qualitative, this is your observations. It's an observable result describing how you use the five senses. So sight, hearing, touch, smell, taste. Whereas quantitative, quality, like you can sense it, like you can see it. Quantitative, quantity, how much. This is the numerical results with units. So a resulted measurement with numerical results and units. And okay, so the base, I lost my face again. There we go. The base units of the SI, or Standard International Unit System, is you're going to see mass, which is typically in kilograms, length, which is in meter, time, which is in seconds. So typically when you say the base unit, when you're talking mass, you're going to see kilograms. When you see length, you're going to see meters. Time is going to be in seconds. And then you have volume, and this is always going to be in usually liters. Like you're going to see a lot of milliliters, or it could be centimeters cubed. It depends on how you are measuring things. And then you have temperature. Temperature is going to be in Kelvin, not Celsius or Fahrenheit. It's going to be in Kelvin. The amount, usually we are dealing with chemicals, so we are going to look at the elements, and the amount of an element is called a mole, like the things that live in the ground, a mole, only not. Each of these is a fundamental unit. These are like the base, what we start with. Okay, so now we've got mass versus weight. So mass is the amount of matter inside an object. So how much there is of you. Whereas the weight is the pull of gravity on an object. So looking at this little dude right here, the mass you can see stays the same, but the weight changes. So this is 10 times the weight because of that gravity pulling down. It's 1200 Newton, whereas on the moon it's only 200 Newton. Okay, so we don't need to memorize all of these symbols and what they mean, because on table D we have your M for meter, and it tells you it's the length. These are the base. Kilograms is mass, pascals is pressure, Kelvin, temperature, mole, that's the amount. Joules is the energy. Seconds, S is seconds for time. L, liter, volume. ppm is parts per million. And M, capital M, is the solution concentrate. That's the molarity. So you got to distinguish between the lowercase and capital Y's. Don't mix them up. All right? So SI, derived units, we're not looking at fundamental, now we're getting derived. what are put together. These are mathematical combinations of fundamental units. So like speed. Speed is meters per second. So it's going to be meters over second. So we're using two fundamentals, combining them to figure out the speed. Heat energy, which we are going to be dealing with. This is joules, which is actually a kilogram meter squared divided by centimeter or second squared. Weight or force. This is a Newton. You saw how I said Newton before for the moon and the earth. This is kilograms times meters per second squared. Here's some more. We've got velocity is meters per second squared. And density, this is a huge thing. Density is meters over volume. One of the things I really like to do is the triangle, where you have D equals M over V. So you've got the D, M, V. I will show you in class. This is a great way to remember density. This is a derived one again. Okay, so we're going to look at these. Switch in your notes to the work page. It should be a green one if I'm not mistaken. You're going to switch to that, and we are going to start getting the measure of. So 36 grams already given to you. It's a mass. We've got grams per milliliter. What is this? It is a derived one. This is going to be grams per liter. That's your density. Grams is mass. Liter is volume. It's a density. Centimeters squared. Well, this is going to be a length. How about meters per second? Do you remember that? Should be speed. Millimeters. This one's going to be length again. Centimeters cubed. This one's a little tricky. It's not going to be length. This is going to be volume. All right, so that's it for right now. If you have any questions, please don't hesitate to ask. And I hope you guys have a great day.